starting with LC oscillations. So LC oscillation, from the name itself you can understand we are talking about inductor and capacitor circuit, right? And definitely the oscillations tell that there might be some oscillations involved. So let's look at this circuit where we have an inductor, and this inductor is joined with a capacitor with a key K2, whereas there is one source which is joined with the capacitor. This is the source which is joined with the capacitor with a key K1. So this is the source and or the cell, this is K1. So this is a cell to charge the capacitor. So let's suppose this is open key, so current doesn't flow here. Now first we are closing the key K1. So when this key is closed, the cell would start to charge the capacitor, right? So in first case the capacitor would start to charge. So once the capacitor is fully charged, we are opening up this key and closing this particular key, right? So now the capacitor is charged and this part is disconnected, and only the circuit is becoming capacitor and inductor, whereas the capacitor is fully charged. When the capacitor is fully charged, the energy stored in the capacitor is there is an electric field with an energy half C into V square, right? So this is the energy, electrical energy stored inside the capacitor. So as soon as you have closed this key K2, what happens? This energy would start to flow and there is EMF produced in the inductor. This EMF would in turn produce the magnetic fluxes, and slowly the capacitor would discharge, whereas the inductor would start to generate a magnetic field or magnetic flux around it. There would be a particular point where the capacitor is totally discharged and this whole electric energy is converted to the magnetic energy, which is half L into I square around this inductor, right? So as soon as the capacitor is totally discharged, the electric energy stored is 0, and this is the total magnetic flux or magnetic energy that is there. So as soon as that point reached, what happens? The magnetic flux would kind of collapse and they would start to charge the capacitor linked to it. So this magnetic field, slowly after it has reached its level, it would start to again recharge this capacitor, and the capacitor would again start to develop the electrical energy and the magnetic energy would start to deploy. And what is being seen, that this kind of thing between L and C, between inductor and the capacitor, keeps on happening, and therefore there is an oscillation that is going on. So what we see, suppose the time start, if we talk about a cycle, then the first quarter of the cycle from the T0, that is from the beginning, to the T4, T by 4, that is the first quarter of the cycle, what happens? The capacitor totally get this whole cycle, capacitor starts to discharge and the magnetic flux starts to develop there, and therefore there is a capacity, or there is a magnetic energy that is getting developed there. Next, quarter, that is T by 4 to T by 2, the next quarter of the cycle, what happens? The magnetic flux starts to deploy and the capacitor with opposite sign, with opposite direction, would start to get recharged. And the same thing would again continue at T half to 3T by 4, and then again it will start to repeat at 3T by 4 to T, right? So T0 to T, the whole one cycle, what we see that first quarter capacitor discharges and magnetic flux takes over. The second quarter magnetic field discharges, the capacitor would take over in the opposite direction. The third quarter again capacitor discharges and magnetic field takes over, and finally again the capacitor comes back to its fully charged position, that is at the beginning. So that is how there is this oscillation between the shift of the energy of electric field and magnetic field between the inductor and the capacitor is going on, right? And this oscillation would generally happen at a frequency that is omega naught root of 1 by LC, or the frequency is 1 by 2 pi root of LC. So at this frequency, this oscillations keeps on going on, and therefore this type of circuit of inductor and the capacitor would very be interested to study. Note one thing, that in this case we don't have any resistor. If there were a resistor, then what happens? There would be a resistive element, and through that there will be the loss of energy, right? So since there is, in this case, this is the ideal case where we are expecting no loss of energy, and therefore the energy keeps on oscillating between the electric field and the magnetic field. But if there is a resistor element, then what happens? Then there is a dissipation of energy or the loss of energy. So this case is an ideal case, even though the inductors and capacitors are there, but in real term all the inductors and capacitors have little bit of resistance, and therefore there are expected to have energy loss, there are expected to have the energy dissipation, and therefore there are some energy dissipation in the real case, whereas this is a very ideal situation where we see the exact energy shift which is oscillating between electric field and magnetic field.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.